Hello everybody, my name is Miss Oliveras and I'm going to be your geometry teacher this year. And I hope you bear with me. We are doing virtual classes and today we're going to start with our first lesson. We're going to learn about points, lines, planes, rays, and segments. So this is what we're going to be able to do at the end of this presentation. You're going to be able to draw points, lines, line segments, rays, and planes. You're going to be able to identify those points, line segments, rays, and planes, and you're going to know precisely the definition of what's a line versus a line segment. You're going to know the difference between those two, the base on the underline notations of a point and a line. Our vocabulary words is going to be a line, point, a line segment, a plane, and an intersection. In geometry, some words such as point, line, and plane are undefined terms. Although these words are not formally defined, it's important to have general arrangement about what each word means. And a point has no dimension. As you can see, when you draw a point on a piece of paper, that is exactly what we are talking about a point. A point is usually represented by a small dot and named by a capital letter. Again, all my points are named with capital letters. A line extends in one dimension. It's usually represented by a straight line with two arrows indicating that the line extends without end in two directions and is named by 2 points on that line. Even though you have a bunch of points in a line, with just two of those points, you can actually name that line and say, what I'm talking about is that line specifically. You can also call it with a lowercase script letter. A plane extends in two dimensions and is usually represented by a shape that looks like a tabletop or a wall. You must imagine that the plane extends without end, even though the drawing of that plane appears to have edges, and is named by a capital script letter or three non-collinear points. And when I talk about three collinear points, it means that 3 points that are not together. Collinear means together, and non-collinear points means 3 points that are not in the same line. A line segment is a set of points that has a specific length. It does not extend indefinitely. For example, if I have a line, I can say I just need that part of a line, and that little part that has a beginning and an end, that is going to be my line segment. It has no thickness, width, and is usually represented by a straight line with no arrowheads to indicate that it has a fixed length, and is named by 2 points on the line segment with a line segment symbol above those lines, above those letters. And the points that we're going to be using is the starting point and the ending point. They're both going to be called endpoints. A ray, in the other hand, is a set of points and they extend in one dimension in only one direction. We have a line that extends in both directions at the same time, while a ray has an endpoint or a starting point that we can call it too, but that point is called an endpoint that starts there and just goes indefinitely in one direction only. When we write that ray, we use that letter, that endpoint first, indicating that we are starting there, and then any other point after that, saying that it just goes on in that direction. And I already talked about this. Collinear points are points that lie in the same line. That means if I have a few points that are together in the same line, that is a collinear point. If they are not together in the same line, that is called a non-collinear point. Now, a coplanar points are points that lie in the same plane, but not necessarily are collinear points. Now let's put that knowledge to the test. Can you see a line there? How will we call that line? Do you see points there? How we would name those points? Is there any collinear points there? How about non-collinear points? Again, try to pause this video, try to answer them, and check out the answer on the next slide. So let's put our knowledge to the test. Here we can see it a little bit more clearly. We have a line, and this is our line, and we have a few points. Now, how do we name a line? Well, a line, we name it with 2 points that are inside that line. So in this instance, I can say that this is line AB. So I'm just going to put AB together, and then this is the symbol that we write to say that that's a line. I can write line AB, or I can just put AB and that symbol right there to indicate that is a line. Now the next question is, what are my points in this diagram? And I have point A, point B, point C, and point D. Again, those are all written with capital letters. The next question is, what collinear points do I have in this diagram? And I can say I have point A and point B as collinear points because they are all in the same line. And collinear points are points that are in the same line. And non-collinear points will be points that are not in the same line. For example, A is not in the same line that C is, and C is not in the same line that D is, but A and B are in the same line, so I cannot put A and B. I would just only have to search for A or B. I can say D, B, C, or D, A, C. It doesn't matter the order. Now let's talk about segment. This is what a segment looks like. It has 2 endpoints, a beginning and an end. It doesn't matter which one is which. It just has one point that defines it. This is an endpoint, and it has another endpoint right there. So how would I name that segment? How many points does that segment have? Again, you can pause this video right here, try to answer it in your notebook, and then check out the answer in the next slide. And you can see that our line segment is going to be called by 2 of those points, with which those points have to be endpoints. So we have point K and point L. If I had another point right here, I couldn't use that one as my segment because my segment starts here and ends here. So I will use KL as my segment. I can also write LK. It doesn't matter the sequence of those letters. They just have to be capital letters, and they have to have a line on top of it to indicate that that's a segment. I can also write as line segment or segment KL, but if I don't want to write all that, all I have to do is just write KL and put a little line on top of it, saying that that is a segment. And in that segment, I only have 2 points. I have point K and point L. Now try to do this one also in your notebook. Use this figure to name each of the following. How would you name a plane? How would you name a ray? What are my points there? Which ones are my coplanar points and non-coplanar points? They're different from collinear points, remember? Once you answer them, please check out the answers in the next slide. So again, a plane, I can name it with 3 points, and I just took point S, point T, and point O to name my plane. A ray has to have an endpoint. We have to start with that endpoint and then any other point that have in that direction. So it says It starts with an I with point I and just continues through point R. And this is the symbol for ray. Instead of writing ray IR, you just write IR and put the little symbol out there saying that that is a ray. Now, what are my points? I have point S, point O, and point T, but I also have point I and point R here, even though they're not in the same plane. Coplanar points are points that are in the same plane, and those points are point S, point T, and point O. The ones that are not in the same plane, those are non-coplanar points, and those are point R and point I. Two or more geometric figures intersecting if they have one or more points in common. The intersection of the figure is the set of points the figure have in common. Again, if I have, for example, two segments or two lines or two rays that are intersecting at any point, that intersection is gonna be one point. So now let's go through our postulates. Through any 2 points, there is exactly one line, and I'm gonna try to draw it. I'm not very good drawing it with my touchpad. You have seen how I draw it. So let's say I have a dot here, and that dot is gonna be a point. Sorry, it's not that pretty of a dot. And I have another one here. And what it says is that the distance between those 2 points is gonna be exactly a line. So that means that I can draw a line through those points. And I'm sorry that my line is not as pretty or as direct as it's supposed to. But again, I'm just using my mouse pad here. So that means that through any 2 points, there is exactly one line, because that is the shortest distance between those 2 points. The second one says that if 2 distinct lines intersect, then they intersect in exactly one point. And again, I'm going to try to draw it here the best as I can. And if I have a line, and I'm going to try to do one in yellow, that turned out pretty cool. And I'm going to try to do the next one in blue. And I'm going to try to do my point in red. So what that means is that if I have 2 lines and they are intersecting, that what it means is intersecting is that they're touching in one point. That intersection is going to be exactly one point. If 2 distinct planes intersect, then the intersect is exactly one line. If instead of being 2 lines intersecting, I would have 2 planes. Imagine those 2 planes being like sheets of paper, and they are intersecting into each other. Imagine those 2 lines being, instead of lines, being planes, like 2 sheets of paper. I just put them in together through the middle. Then that intersection is gonna be a line. And you can actually draw a line between those 2 papers if they are intersecting, if they are smashing through one another. In our fourth postulate, it says through any 3 non-collinear points, there is exactly one plane. And what it says is that if I have 3 points and those 3 points are not together, that means that they form a plane. Now you will say, but Missy, why teacher, why just 3 points and not 4? Well, that is easy. That is because I technically can actually build a plane with 3 dots. All I have to do is put all those dots together and I make a plane. And you're gonna say, but isn't it supposed to be kind of squarish? Well, it doesn't matter actually. We use that square as a representation, but it can be any form whatsoever. Remember, a plane just continues on and on in the same place. is it is not constricted by just what is inside it. So if I have 3 points, that means I can actually construct a plane. That's all I need to do is just have 3 points. If I have more than 3, then better. But I cannot make a plane with just 2 points. With 2 points, I can only make a line. Now, let's check out this figure. And I know it looks kind of weird. Don't worry, I'm going to be explaining it. And we have a plane, and this one is squared. And most of them are going to be representing as squared. But again, only with 3 points, I can actually name that plane. And this plane has a line in it. It has a segment in it. And it also has this line that goes through it. I don't know if you can see those that line being dotted here. That just means it's going through it. Just like if you will punch a paper with a pencil, the pencil will be that line and the paper will be that plane. And they're going to be touching in the same, they're just going to be intersecting, they're going to be touching in one point. And it says here, name the intersection of line QC, and you can see that's a line, and the segment WU. Again, it says name the intersection of the line QC and the segment WU. You're gonna look at them. You have here the line and here the segment, and they are touching in just an exact one point. And what point is that one? If you said point T, you are correct. Remember, this one is the S one, and this one is the T, this one is the B, and this one is this D. So let's try not to confuse them. Now, name the intersection of that plane, that whole thing, that plane pi. Here's the name of that plane. It's called name pi. And the line DB. And this is our line DB. Just like if we were punching a piece of paper with a pencil, what is that intersection going to be called? And again, if we have a plane and a line, our intersection is going to be in exactly one point, and that point is going to be point S. Good job. Now name two opposites rays at point T. So what it says that I have point T. Where are those two rays? Remember, a ray has a start, but it just continues through the other way. If you said TQ, ray TQ, and ray TC, you were correct. As you can see, they have an endpoint. They start right here. They continue through C, and just this in that line just continue through there. So we have here our first ray. I'm going to try to highlight it. So we have here our first ray, and we have here our second ray. They're both are sharing point T. Now, what's another way that we can name a plane? Now, I know that this plane is called plane pi, but I also told you that you can name a plane with just three numbers. With just 3 points. So for example, I can say that this plane is plane T, S, and U. There are 3 points that are coplanar points. Now I have something different here. I have 2 planes and they are intersecting into each other. Again, it's like a piece of paper. I have one here and I have the other one right there. When you see this dotted line, it just means it's behind that figure. So one of those plane is gonna be called plane pi and the other one is plane T. And it says name the intersection of those two planes. And if you remember our postulate, it says that an intersection of two planes is a line. So we're going to be looking for a line that is between those two planes. If you said that was line BS, you were correct. And I'm going to try to highlight it right here. As you can see, that is a line that is intersecting plane T, and I'm going to try to highlight that plane right here so you can see it with another color. And plane pi, and plane pi. Sorry, I don't have the best pause here. There we go. So maybe you can see it a little bit better here. I have this plane and I have the other plane, and this line that you can see right there is intersecting them. It's exactly in the middle of them. And again, when we write what is a line, we use that little symbol on top of those letters. We use two capital letters, those are points. And with those 2 points, we just use that sign to say that is a line. What is another name for plane pi? And I'm going to try to highlight that plane. And again, you can name it different ways. You just need to have 3 points on that plane to say that is plane pi. If you said point L, point M, and point G, you were correct. Remember that point C is being shared in the plane T. So I would say point L, point M, and point G are points that are exclusive from my plane pi. So I can say plane LMG. Now name the intersection of a line MG and the line BS. And I'm going to first try to locate it. I'm going to look for my highlighter here. And I have here line MG. And I have line BS right here from B to the S. And I'm going to look that intersection. Where are they touching? If you said that they were touching in point C, you were correct. That is our intersection, and an intersection between two lines is just 1 point. Now name a point that is collinear in M and C. Again, I have point A, and I'm going to try to, point M, and I'm going to try to highlight it. And I have point C. And I need another point because I'm asking what is another point that is collinear? Which one are they sharing with a line? If I said S, that would be wrong. If I said B, that would be wrong. What are other points that are in the same line? If you said point G, you were correct. Again, I'm going to try to highlight it. We have point M, we have point C, and we have point G. And they are all in the same line, and that is what they call a collinear points. Now I have something a little bit different here. I have two planes. I have plane T right here, and I have plane pi down here, and they are being intersected by a line. And they're asking me, name the intersection of plane pi. So I'm gonna put my attention to this plane right here. And what is intersecting it? Line LC, very good. Now, remember that when I told you that when a line intersects a plane, it's intersecting in just 1 point. So what is it called, that intersection? If you said point C, you were correct. You have a plane, you have line LC, and you can see that is intersecting in point C. Name the intersection in plane T. Again, now we are putting our attention into this plane right here and the line LC. And what is intersecting it? Again, we have a line, one plane. That means it's going to be intersecting in 1 point. If you said that the intersection is point L, you were correct. Name a point that is coplanar with H and L. So first let's try to find H and L. What other point is in the same plane that H and L are? If you say point P, you are correct. We have again a point H, point L, and point P in the same plane. Name the opposite ray of ray CB. And the opposite of a ray is just that same ray, but that is going in the opposite side. So first let's look for our ray CB. Just gonna use my highlighter here. It starts with the C and goes through B. That is my ray. So what is the opposite of that ray? If you said ray CG, you were correct. I'm going to show you again. We have a ray that starts with the endpoint C. It continues through point B. That is our first ray. And the opposite of that ray, it starts with the same point C and just goes through the other direction. And that's all you have to know about the basics of geometry. And now all I want you to do is go to your textbooks and remember that textbook has to have the Common Core Edition logo on the cover of it, and go to page 9 and 10 and do those exercises. Once you have done them, go to the link below here and just write the answers on that Google form. That Google form, that link there is going to be my evidence that you have done that homework. I hope you enjoyed this short presentation and have a nice day. We'll see each other on the next virtual class.